Y, this is Z, rotation in X. Okay, so we have the whole thing. Okay, so I'm just going to sketch this out. Okay, and then this is built in, and then we have two lines here, so you know where we're looking at. Okay. Then we find our centroid over here. Okay, and then we have our element A, and then we have our element B. Then we put our forces. You have 100 kilonewton over here. You have 25 kilonewton over here, right? And then you have 8 kilonewton per side. Okay, right? So ignore the cross and dots. Okay, just focus on the full actual arrow. Okay, so the first thing we're going to do from here, this view, there's a lot of component, right? We know that PZ, there's a axial load in the Z, and it's going to be due to the 100 kilonewton and its compression. So we know for this PZ, you're going to use stress Z is equal to PZ over A, right? So in this case, element A and element B will be under what? Compression. Negative means is what? Compression. Okay. And then the next thing we are going to look at is the moment about the x-axis. Okay, so I'm going to have clockwise as positive, so moment about x. Okay, so this is where things get really interesting. Okay, there are two things causing moment about x. One is your what? One is your 100 kilonewton, and the other one is your 25 kilonewton. So the 100 kilonewton, which is parallel to the centroid, the perpendicular distance is here to here. So on. So that is the perpendicular distance. Okay, so this is the perpendicular distance. Whereas the 25 is this distance from here to here. Right, this is a very interesting problem, yes or no? One is towards the element, the other one is towards the what? The centroid. And I give you the reason why already. So we know that this is 0.5 meters. And then the distance over there, right? So this is basically, if we look at the structure, this is basically this distance from here to here, right? So it's D divided by 2. So it's 0.205 divided by 2. Right? So both are in the same direction. So 100 times 10 to the power 3 multiplied by 0.205 divided by 2. plus by 25 times 10 to the power 3 multiplied by 0.5. So this will be equal to 0.205 divided by 2 times by 100 power 3, 10250 plus 25 power 3 times 0.5 is 12500. So this will be equal to 10250 plus 12500 is equal to 22750 Newton meter, and it's going to be this direction, right? So we know that this is your moment in X compression tensile. That's why the moment vector is so helpful now. So we know that if we are going to look at moment in Z, which is equal to mx over ixx multiplied by y, right? We know that element A is going to be under tensile positive. And we also know that element B is equal to 0 because it's at the where? It's at the centroid, right? So we can get all this information out. Now, we have to be careful with the shear, okay? So we know that Vy, right, is equal to 25 times 10 to the power 3 Newton. But we cannot say is Vy is element A is equal to 0. Because now we have to go into thin wall analysis. Okay, so let's see what do I mean. So if we go over here, right, the shear we have to be like very, very, very careful. Okay, the shear you have to be very, very careful. So we know that we have a what? We have a Vy, and this Vy is 25 times 10 to the power 3 Newton. And over here, this is our element A, and over here, this is our element B. Element B is easy. We know that it will not be equal to what? We will not be equal to 0 due to Vy. Okay. So now if we were to sketch the shear flow, right? This is nothing new. You've done it before, right? We know that the web control the direction, right? So this will do this, this will do this, this will do this, and this will do this. And element A is down here, right? So for this case, based on thin wall, okay, based on thin wall analysis, when we apply, right, the shear stress is equal to Vy over Ixx Qx divided by T, right? So the thickness over here, we know that this is the thickness, right? Right? So we can get the information over there. And what we conclude over here, that element A is not equal to 0. Element B will be equal to the shear what? Max. Okay. So you have to be very cautious over here. Okay, when we apply into thin wall analysis. Okay. Then from here, do we see anything else we need? We have no, nothing. So let's go to another view then. Okay, give me another like 4 minutes the next view, I hope, will be pretty quick, I hope. Okay, so we go into the next view now. So the view that we're going to do now is we're going to look at the YX view now. Okay, or we're going to view on the YX plane. So we know that this is our ZX plane, and this is our X. So again, I'm going to sketch this out. Okay, it's going to look like this. Okay, and then I'm going to draw the dotted line, the hidden detail of the web. And we know that this is built in. And then we know where is our element A. And we know over here, this is our element B. Okay. Then we have to draw our centroid. So here's our centroid. Okay. Let me undo. So here is our centroid. So from here, we put in our forces. Okay. So we know that we have a 100 kilonewton coming in. Hey, wrong color. Come on. We have a 100 kilonewton. We have a 8 and 8 kilonewton coming here. And somewhere over here, we have our 25 kilonewton. And then we are going to draw our rotation in Y. Okay. So we know from here that we have a moment about Y due to the 8 kilonewton, twice 8 kilonewton. And it's perpendicular to the centroid. So your distance to take is you take the distance to the element. Okay, you take the distance to the element. So that distance is equal to 0.6 meters. So we know that, so I'm going to call anti-clockwise as positive now. So moment about Y, okay, from point A is equal to twice 8 times 10 to the power 3. And then multiply by distance 0.6. Okay, because there are two 8s. Okay, so 2 times 8 power 3 times by 0.6 is equal to 9600 Newton meter, and it goes this way, right? So when it's going that way, right? So we know that this is moment Y. So we know that this is compression, and this is what? Tensile. So what you can see over here, right? So you know that stress Z is equal to my over Iyy multiplied by x. We know that element A is going to be in the compression mode. And we also know that element B is going to be in a tensile. Okay, because one is on the left side of the centroid, one is on the right side of the centroid. Okay, I'm going to stop here now. Okay, and then I'm going to continue this example on Thursday. Okay, thank you for your time. I will stay behind. If you have any question, you can ask me.